Imagine we have a 400 by 400 image inside of a scroll view. While it's bigger than the scroll view itself, we don't have a problem when the user zooms in. However, when it shrinks down to say 200 by 200, it's just stuck there in the top left corner. To fix that, we can add space around the image to position it in the center. We already have all the information we need. We know the size of the scroll view, and we know the scaled size of the image. We just need to find the difference between the scroll view size and the image's size in both axes. Once we have the difference in width and height, we'll chop both numbers in half to find out how much space should be on each side of the image. There are a couple of ways to apply those numbers. You could change the frame of the subview directly, or you could set the scroll view's content inset property. As I said, we want to center the image instead of having it stuck to the upper left corner. To set up the code for that, create a new method named centerImage. In order to determine where the center is and how to place our image there, we need both the size of the scroll view and the size of the image frame. With both of those sizes, we can now calculate the space that should be surrounding the image. Start with the horizontal space. First, check to see if the image size is less than the scroll view size. If that's the case, then subtract the image's width from the scroll view's width. Divide it by 2 to get the padding for one side. If the image's width is not less than the scroll view's, then we want 0 padding. We can do exactly the same thing for the vertical spacing, so copy and paste your work. Name this one vertical space and replace width with height.
At this point, we have the horizontal space and the vertical space calculated. To apply those to the scroll view, we need to use its content inset property. Set that to a UI edge insets and pass the spacing into the initializer. Use vertical space for the top and bottom and horizontal space for left and right. Now we have to call this method. Again, we'll call it in viewDidLoad so that the view will be centered when the app starts. We also want to center the view each time the user rotates their device, so add it to will layout subviews as well. Time to build and run.
When the app starts up, the image is centered vertically with equal spacing on the top and bottom. And if we rotate, it's centered horizontally. We still have the power to zoom, and if we rotate after zooming, the view will still recenter itself.
Remember, a scroll view determines whether its content can be scrolled through the content size. So far, we've been manually setting that property. It's time to let auto layout do the work of calculating the content size. With an image view, auto layout can use the intrinsic content size of the image. All you need to do to make that work is pin the image view to all 4 edges of the scroll view. Let's try implementing the simple case first before we move on to more complex layouts.
We've got another basic sample app set up for you here with several images included. In main.storyboard, start by adding a scroll view from the object library. Constrain it to the safe area on all sides with the Add New Constraints menu. Then add an image view to the scroll view. Set the image to the zombie image, and the content mode to top left. If you click on this red arrow, you'll see that the scroll view has no idea what the size of its scrollable contents are.
We've solved this problem in a few ways before, but now we're going to fix it using auto layout. Select the image view and constrain it to the scroll view on each side. Build and run. And you should have a working scroll view. There was no code required to do this. Auto Layout is automatically using the size of the image to determine the scroll view's content size. To really test that out, change the image to the vampire toucan. Build and run again. And it still works. The scroll view's content size exactly matches the image we set.
I expect you'll often want to scroll through a screen with more than just an image in it, so let's create a simple layout that we want to scroll through vertically. Delete all the constraints on the toucan. And zoom out, and then drag the image view to be smaller so it fits inside of the view controller. And set the content mode to aspect fit. Now add a label. Change the text to Vampire Toucan. And change the text style to Title 1. Below that, add a text view. We'll need some text to go in here. We've added a description for the Vampire Toucan in this text file, so copy that and paste it into the text field. And finally, change the text style to body. At this point, we've completely run out of space in the view controller, but the whole point of using a scroll view is to have more content than fits within a screen, so what do?
We can give ourselves more space in Interface Builder by selecting the view controller, going to the size inspector, and changing the simulated size to freeform. Now you can set the height to something bigger, like 1400. Changing this only affects what you see in Interface Builder. It obviously can't change the physical size of your phone, so you're not doing any harm here. You may need to drag the scroll view down so you can see what you're doing. And now that you have more room, drag that text field out so you can see all of the text. Then below that, add a small image view. Control drag and let go, then hold Option to constrain it to a 1:1 aspect ratio. This will eventually force the image to be a square. And set the content mode to aspect fill. Then make 2 copies and set the images to the skeleton, muscle, and surface drawings. We're back to where we started when we first added the image view. The scroll view has no idea what size its contents are.
We could manually constrain all of those views we just made, but really, what we would normally use in this situation is a couple of stack views. So stack the 3 small images together horizontally, and then stack everything together vertically. And now we can constrain those stack views. Currently, all of the images are much too large. First, change the view controller's simulated size back to fixed. Then constrain the parent stack view to all sides of the scroll view, just like we did with the image view at the start. Everything is still much too large.
If we were not using a scroll view, those constraints would have wrangled the stack view into the right size. But a scroll view gets its content size from the content. Subviews don't inherit their size from parent scroll views like they do from other types of views. Here are some important points to keep in mind when using scroll views. In order to use auto layout to determine a scroll view's content size, both the size and position of all subviews must be set either by intrinsic size or constraints. When you constrain a subview's edges to its scroll view's edges, that will only set the subview's position relative to the scroll view. To set the size, you'll need additional constraints. In practice, that means you'll have to set more constraints than you may be used to specifically define the width and height of views. You can do that by using hard-coded values or by constraining a scroll view's subviews to something else with a defined size. Both the root view and the safe area are a good place to start, but you can also use the width and height of the scroll view itself.
Let's start with this big top image. I want to make it half as tall as the view controller, so constrain the Vampire Toucan's height to the root view, and then edit that to be half the height. Next, constrain the width of the parent stack view to be equal to the width of the scroll view. Now, this stack view is constrained to the scroll view in two different ways. First, the edges are all pinned together, with another type of view that would also effectively define the width and height of the stack view. But with scroll views, you have to set those explicitly with another constraint, like this width constraint. We can also set a negative constant, let's do -40, on that width to give us some space from the edges of the screen. And to apply that equally on both sides, add a constant of 20 to the leading and trailing constraints. Now, to get this looking exactly how we want it, set up the stack view's properties in the Attributes Inspector. For the parent stack view, set the alignment to fill, distribution to equal spacing, and the spacing to standard. We actually want this label text centered, so change that now. For the horizontal stack view, leave the alignment at fill, and set the distribution to fill equally with a standard spacing. Now the parent stack view's width is set based on the width of the scroll view, and the height is based on the intrinsic content size of its subviews. The horizontal stack view is getting its width from the parent stack view. That width is also setting the height for the stack view because the images are each constrained with a 1:1 aspect ratio, and we've said they should be distributed equally.
If you try to build and run now, your text view may be completely missing. That's because a text view is also a scroll view. We'll talk about nesting scroll views in a future video, but for now, what you need to do is turn off that scrolling capability. Back in Interface Builder, select that text view, and in the Attributes Inspector under Scroll View, uncheck Scrolling Enabled. Now, build and run one more time. And you can scroll through to see the entire layout.